Yeah. Uh, just a second. Okay, cool. Hmm. Just put it on. Yes, okay. Okay, cool. So can I start?
Yes, you can start.
Okay. Okay. Uh, Hello. Hi all. Can you can you guys give a thumbs up if you're able to hear me on the comment here? Uh, okay, cool. So I assume like all of you guys attempted the CPAT today at 6. Um, so let me just create. Let me just ask you like how difficult did you find it? Did you guys find it easy, medium, hard? Can you guys comment on the comment section before we start? Okay. Aditya says it was a bit hard. Um, Anyone else? Uh, okay. So okay. So let me start off with the questions uh, immediately. So okay. So the first question was yeah. Consider like suppose you are in a bank and you can make transactions only in multiples of 6, 15, and 21. Okay, and initially you start off with a balance of 0. Then which of the following can be your balance after some transactions? So the options were 99, 100, 1, and 3. So yeah, what did you guys attempt? Like, can you guys give a thumbs up here if you got it right during the test, and a thumbs down if you got it wrong? Okay, so we have 3 people who got it right, but there are approximately like 24 people here. So okay, for people who are just joining, let me recap the question. So we're going ahead with the first question that says uh, consider a hypothetical bank where every transaction is a multiple of 6, 15, or 21, and initially you start off with a balance of 0, and which of the following 4 options could be your balance at some point in time? Did everyone get the question? Is there someone for whom the question is not clear? Give a thumbs down if you didn't understand the question. Okay, so I have a confused face. uh, right, so let me have a go at explaining the question again. So uh, yeah, so let's say you have a bank account and the only transactions that you can do are either add 6 or subtract 6, add 15, subtract 15, add 21, or subtract 21. Okay, so so one possibility could be in one transaction you added 6, then you added 15, then you lost 21, then your net balance would be 0. Okay. Oh, sorry, I forgot to share my screen. Sorry for that. Uh, Share screen. Can you guys see my screen? I guess not. Okay. Why am I not able to share screen? Just a second. Let me. Uh, Shortcuts. Channel controls. Okay. Why am I not able to share my screen? Just a second. Okay, I can upload file, but why can't I share my screen? Can you guys see my screen? Uh, uh, okay, let me just refresh. Okay, can you guys see the PPT that says CPAT 2 solution discussion? Okay. Uh, how about slide? How about uh, how about that? Can you see something that I'm scribbling here? Okay, cool. Uh, there's a slight delay, but yeah, I mean, yeah, this is the first time that I'm taking a class. Sorry. Okay, so the first question. Oh, damn. Uh, class settings, more screen. Doesn't work. Just give me just give me 2 minutes. I'll see if I can fix this. Simple. This. Okay. Yeah, so let me just work with this. Okay, so cool. The first question is, let's say the first question is, you are allowed to make transaction in multiples of 6, 15 and 21. Okay, and can you have a balance balance of 3, 99, 100, 101. Ouch, 101. Sorry for that. Right. So okay. So the first observation that you have to make is that since you are allowed to make transaction only in multiples of 6, 15 and 21, okay, and you start off with 0, right? So every time your balance will be divisible by 3, right? Because initially it's 0 divisible by 3, whether you add 16 or you add 51 or you add 21 or you subtract 6 or you subtract 15 or subtract 21, the balance will always be divisible by 3, right? So because of that, you cannot have a balance of 100 or 101. Okay, so you can have either 3 or 99. Okay, and right. So how many of you are familiar with Bezout's I mean, if you are familiar with Bezout's theorem, then this is basically straightforward. But how many of you are familiar with Euler's GCD function? Can you put a thumbs up if you're familiar with Euler's GCD function? Okay, so basically if you want to get the GCD of two numbers, GCD is the greatest common divisor of let's say 3 and let's say 6 and 15. Okay. What you do is you replace the larger number by the remainder when it's divided by the smaller number. So GCD of 6 comma 15 equals GCD of 6 comma 3 equals GCD 3 comma 0, and that's 3. So I mean, this is standard 10 standard maths, right? You should all be familiar with this. So yeah, so what you can do is here, what I can write is, I can write 3 equals 15 minus 6 into 2. Okay, 3 equals 15 minus 6 into 2. So like that, if I have any two numbers, a comma b, ouch, I can always find integers x comma y such that ax plus by is g. So how to do that is, you simulate Euler's GCD function like so, and then you just go back in reverse, and you can reconstruct g as a sum of multiple of a and a multiple of b. Okay, so from that, so any number divisible by 3 you can make from these three numbers. So 3 and 99 are the right answers. So did everybody get that? Okay. I'll go to the next one then. The second one is interesting. You have the following function f of n, and if n is less than 0, you return n minus 10, and otherwise n plus 10, I believe, n plus 10. Okay, otherwise you return f of n minus 11. Okay, so this is a recursive definition for function f, and the question is, what is f of 2 power 1000? Okay, did everybody get the question? I just put a confused face if you didn't understand the question. Cool. So this is actually based on McCarthy's 91 function. If you guys haven't heard of it, please Google it. It's the same definition, but the constants are a bit different. So let me just put a link here to McCarthy. Okay. So that's a Wikipedia link to McCarthy's 91 function. If you already knew about this function, then you can easily answer it. But so other thing you could have done is, during the quiz you could just copy this into a program and run it. So this is a famous recursive function that has whose value is constant after n equal to minus 1, and it's not obvious at all why that should be true. I mean, if you kind of think about it a little bit, since you're just returning, maybe there's some suggestions that f is constant, but not at all obvious. And if you try to simulate this by hand for some small numbers, 1, 2, 3, and so on, or if you create a program for it, you will find that f of n is 9 for all values of n greater than or equal to -1. Okay, so f of 2 power 1000 is also 9. Okay, cool. So yeah, by dry running test cases also you can find that the function is constant for a lot after 1 2 3 they're all 9. So that's one way. Yeah, that's the easiest way to do it. Just copy it and implement it. um, okay, am I not audible? Okay, cool. uh, so that's the second question. Okay, let's move on to third question. Okay, uh, third question is, how many solutions are there to this equation? Okay, so I mean, if you have solved questions, x and y must be integers. uh, Let me say belong to z. Okay, so if you have solved these kind of equations in the past, I mean, a quick way to do it is to prove that there are no solutions. So in general, solving questions like these for integers is a bit hard, but the three is suggestive here. So if you just consider left hand side and right hand side modulo 3, or what will be the remainder when left hand side and right hand side is divided by 3. Okay, so 2021 leaves a remainder 2 when divided by 3, as this is divisible by 3, so the right hand side leaves remainder 2 when divided by 3. Okay, right hand side modulo 3 is always 2. Okay, and left hand side modulo 3 can be 1 squared, minus 1 squared, or 0 squared. Yeah, so left hand side, so for any integer x, the left hand side can never leave a remainder 2 when divided by 3. Okay, so that shows you that left hand side cannot be equal to our right hand side for any value. But why 3? Well, I mean, that's the difficulty of the question. So you should be able to, that's one solution, right? So it's obvious that, or if you do a bit of number theory, you know that x square modulo 3 will never be 2, and then some keen observation will tell you that right hand side modulo 3 is 2. So that's one reason. But I understand it's not concrete, but yeah, that's one way to solve the problem. So that's why it's maybe a bit hard for beginners who haven't seen these kind of equations before. So I got a comment saying that someone did this by drawing a graph. Can you elaborate? So so I just like to point out that you have two variables here, x and y, and x and y are integers, right? So they could be positive, they could be negative, etc. So I'm not sure how you argued that. I mean, how you draw a graph to draw that conclusion, but in real numbers there are infinitely many solutions. So you can just fix x to be whatever you want, and you can get whatever y you want. But in integers there are no solution. Okay, and one way to prove that is by taking modulo 3. Very simple, right? So let me go to the next question. This is an interesting question. So f of n is floor of n by 1 plus floor of n by 2 plus so on till floor of n by n, and you're asked to find f of 3 power 100 minus f of 3 power 100 minus 1. and right. So this is an interesting question. Also, intended to be a medium to hard question for for even experienced people who are trying out this quiz. So yeah, it's not an easy question at all. So if you didn't get this, I mean, if you couldn't answer this question, I wouldn't. I would say that's perfectly normal. But okay, so this test is supposed to be an introduction for you to for you to computer programming. So if you so the reason I imagine that most of you are class 11 12 people, or even first year students if you are, and if you are familiar with the mathematics behind that's there for class 11 and 12. This is to show you what kind of concepts are involved in comparative programming. So if you enjoy solving these kind of questions, then you'll probably enjoy comparative programming as well. Yeah, so even for class 10 student. Okay, so for these questions, I don't particularly say you need. So there are some questions that are very mathematical, that needs mathematics beyond class 10, but there are very few. Like this question doesn't require a lot of mathematics per se, but it's a tough question. I'll come to the solution later, but yeah, the reason why these kind of mathematics questions are asked is because if you have, or if you like solving these kind of questions, then you will enjoy comparative programming. So if you did enjoy this quiz, then, and you are you don't know what comparative programming is, then yeah, I would encourage you to go to sites like CodeChef, Codeforces, and try your hand at problems there. So yeah, that's why we had these kind of questions. Cool. Okay, so right, so this was in comparative coding, do maths really come so much? I wouldn't say it comes as much as the problems asked in in this quiz, but let's say they are somewhat similar. I have tried HackerRank, in that it was not so much. Well, you have to try a bit more. There are some questions that questions in number theory, especially maybe even computational geometry, that requires some math. But yeah, there are a lot of questions you can solve without math also. And I hope there were a lot of questions here that didn't involve a lot of maths as well. So yeah, okay, so let me quickly get to this question. Okay, so yeah, we are asked to find this difference. So let's see what f of let's see what f of n minus f of n minus 1 is. So that is summation n by j minus n minus 1 by j running from 1 to n minus 1 plus 1. Okay, so this is n by n. Okay, so what I've done here is I've just rewritten this in this form. Okay, so is this okay for everybody? I assume this is okay for everybody. Okay, so let's consider this expression. Okay, and let's consider how n by j changes as n changes. So in this difference, what's happening is j is same, but n increases by 1, right, from here to here, right? Okay, So if you consider n by j for values from 0, 1, 2 and so on up to n, what happens is so on up to infinity. So for 0, n by j is 0 irrespective of what j is, and then up to j up to j minus 1, you have floor of n by j is 0. So I assume everyone knows what floor is, right? Is there anybody here who doesn't know what floor is? Give a confused face if you didn't know what floor is. Okay, so this notation probably should have been explained in the GIF. Yeah, exactly, it's GIF. This is the floor of x is the smallest integer less than or equal to x. So floor of 1.5 is 1, floor 2.5 is 2, 2.99999 floor is also 2. Okay. So if you didn't know what GIF is, then this question was a bit out of reach for you. But assuming for those people who knew what GIF is and who tried out this question, let me just add a new slide. Okay, so consider the values of n by j. So 0, 1, 2, so on. So up to j minus 1, the answer is 0, right? Then from j to 2j minus 1, the answer is 1. Okay, and then from 2j to 3j minus 1, the answer is 2. Okay, so essentially what I'm doing here is I'm plotting n by j for different values of n. Okay, and what I observe here is that n by j increases at only multiples of j. This is kind of obvious, but I just wanted to represent it like this so that you can understand it better. So n by j increases only if n is divisible by j. Is that clear for everybody? I see a couple of confused faces. Okay, so right. You understood this, right? From 0 to j minus 1, floor of 1 by j, and so on till floor of j minus 1 by j. All of these terms are 0, right? Because they're all less than 1 and they're greater than 0. So all these terms are greater than 0 and less than 1, right? Because obviously, right, all these terms are less than j and the numerator by denominator is less than 1, right? And then I can write for these terms I can write them as j plus 0 to j minus 1. So I can write this as j plus 0 by j, j plus 1 by j. So this segment I can rewrite as 1 plus 1 by j, 1 plus 2 by j, and so on till 1 plus j minus 1 by j. And the largest floor of this guy, they are all 1 because this is same as 1 plus floor 1 by j, 1 plus floor 2 by j, and so on. 1 plus floor j minus 1 by j. Or you could also say it's obvious by looking at these numbers. So for this segment the answer is 1, for this segment the answer is 2, etc. And so considering n by j, what happens is as n increases, right, n by j can increase by only 1 from 0 to 1, from 1 to 2, etc. And it will increase only if n is divisible by j. So coming back to the previous slide, what happens is a lot of terms here are going to be 0. This will be 1 only if j divides n. Right? So only for j from 1 to n minus 1 that is a divisor of n, this sum will be 1. For others it will be 0. And then here you have n by n. Right? So this expression is say equal to number of divisors of n. Did you guys get that? So that's the tough part of this question. So this is equal to number of divisors of 3 power 100. Did you guys get that? So the person who has a confused face, can you explain what part you didn't get? Okay, so then I'll just move on because there are like a lot of questions to discuss. Right. So okay. So yeah. So the number of devices of 3 power 100. So what are the devices of 3 power 100? Simple: 3 power 0, 3 power 1, 3 power 100. These are the devices of 3 power 100. So the answer is 101. Okay. So if you understood it, can you put a thumbs up? Cool. I got a couple of thumbs up. Right. So let me move on to the next question. The next question is a simple oops question. So if you are in class 12 and you know what oops is, you must have heard of data hiding. So does anyone have so the question is what is the purpose of having data hiding in oops? And the options are before I go over the solution, does anybody have a doubt in the question? I thought this was a simple question and I'd like to skip it if did anybody have a wrong answer in this question? If you can put in the chat, then I'll discuss it further. Okay. So just in one line explaining this is the purpose of having data hiding is to abstract data and to put it all in one place so that it's easy for people to read and understand. So that was this question. Okay, so coming back to the next question. Okay, slide. Okay, the next question is simple. Ouch. Let's say you have 2 points D and E and a circle here with D and E diametrically opposite to each other, and assume that the circle is an obstacle, right, and you can't move inside it. What is the shortest path to get from D to E? So one way would be to go like so, like this. You can go like this. And the question is, what is the shortest path? Okay, and how you can think of it is think of if you had a rope bit tied at these two ends, D and E, or an extensible rope, and you introduce this circle in between. Okay, then how will the rope be screwed? It'll look like so, from here to go to the tangent and then like this. Okay, so this is the shortest path from D to E. So here what's happening is at every instant you're moving closer to E, as close to E as possible. So this is the shortest path from D to E. Okay, and you can show that the other options aren't valid, or this is better than options like this one, and options like this one. This was another option. You go tangentially and then so from D move to I, and then so this was another option. And here you can show that this arc length is shorter than the sum of these two distances. How to show that is, so you have this, you have a tangent here, say this is R, so this arc length will be r theta in radians, and this segment length will be r tan theta. Okay, and if you plot the graph, you see that tan theta is always greater than or equal to theta. So this line segment is always greater than this arc length here. So this option is better than this one, definitely, in all cases. And then coming to this one, okay, so here you have some distance d here, some r, so this will be square root of t plus r the whole square plus r square, and then this is let's say d plus pi r 2 pi r by 4 or pi r by 2, and you can show that this is shorter than this one for all values. But essentially the idea is to find the shortest path, you should always move along a path that leads you closer to the destination E. And one way to figure that out is, like, assume you have a rope tied between the points D and E, and if you bring a circle in between, how will it get skewed? And this will be roughly the path of that extendable string, and so this would be the shortest path. Okay, so any doubts in this question? Like, put it in the comment box if you had some doubts. Okay, so let me get to the next question. Right, next question is, let's say you have alpha 1, alpha 2, so on till alpha k, and there's a typo in the question. There was a typo in the question. It was given that alpha k are real numbers, but that was a mistake from our end. So I would like you to consider alpha 1, alpha 2 and alpha k to be any number. Okay, and alpha 1 power n plus alpha 2 power n plus and so on till alpha k power n are all integers. Okay, for all n greater than or equal to 1. Okay, and the question is, what can alpha be? Okay, and the options were square root of 2, pi, e, and 1 plus I. Okay, okay, so you can easily construct for square root of 2, square root of 2 power n minus square root of 2 power n, plus minus square root power n. So if n is odd, then this will be 0, and if n is even, then this will be an integer, obviously. Okay, so this is one expression that is always an integer, so square root of 2 is correct. And then similarly for 1 plus I, you can have 1 plus I power n plus 1 minus I power n, and this is always an integer. You can check it out. This actually repeats after or there's a pattern for this, and you can just show that this is an integer for all numbers. But what about these two numbers, pi and e? So again, this was meant to be a hard question for people who are experienced and they are attempting this quiz. We wanted something for them as well. So to say, I mean, at least you can guess that the answer is only a and b, because pi and e are very irrational they are transcendental numbers. But let me just give you the identity that this question is based on, and a lot of linear recurrences are also partially based on this, I'd say. Just put the Wikipedia link here for your reference. So this is, I don't want to spend too much time on explaining the identity, but essentially what the identity says is it's a relation between roots of a polynomial or sum of powers of roots of a polynomial and its coefficients. Okay, you might have solved questions like given a polynomial or quadratic polynomial x square plus ax plus b, and alpha beta are the roots, find alpha square plus beta square. Like, these are some standard JE questions that you might have solved or you might be solving for JE. But this is kind of a generalization of all that stuff that you've been doing. So there's a relation between the coefficients, let's call them x power n or x power k plus e1 x power k minus 1, so on till ek. There's a relation between these coefficients ek and let's say pk equals sigma alpha a power k. There's a linear relation between them, so you can write pk equal to some function of eks and pk minus 1. So the idea is that if pi and e are if there are some other numbers alpha 2 to alpha k such that and alpha 1 being pi or e, then there will exist integers here or rational numbers e1 to ek for which pi and e are roots. Okay, and it's well known that pi and e are transcendental numbers and they are not roots of any equation. So the answer cannot be pi and e because of those reasons, and a and d are valid options. But again, by elimination and some intuition, you can probably guess that a and d should be the only options. So any questions? Okay, if not, I'll get to the next one, which is very simple. There are 7 classes and they are scheduled amongst 5 days. And there are like 4 options. There must be at least So the correct options are there must be at least one day with more than 2 classes, and there can be maximum 3 days with more than 1 class. So any like, if you guys remember this question, any doubts? This was meant to be an easy question. Can you guys put a confused face if anyone wants some further explanation for this question? So some examples would be scheduled all classes on the first day. So here there's only one day with more than 2 class, and then if you want maximum number of days with more than 1 class, then 2 2 2 1 0 is a solution. So yeah, this was meant to be an easy question, and I'll just move on to the next one. Okay, so the next question is interesting. Let's say you are in charge of scheduling flights for an aircraft, and you want to schedule minimum number of flights. Okay, and all flights are two-way. So that means if there's a flight scheduled from A to B, then there is one flight that goes from A to B and one flight that goes from B to A. Okay, and every flight has a profit. Okay, and the third criteria is that you want to maximize profit. Okay, and you also want to maintain that from any city you can go to any other city. Okay, so suppose there are k cities. Okay, how many flights will be scheduled? Can someone answer? Let's say you have k cities, 1 2 3 4, or let's say you have 4 cities. How many flights should I schedule such that, how many two-way flights should I schedule such that from any city I can go to any other city? Can someone answer in the chat box? Any ideas? Or let me give an example. From 1 to 4, 4 to 3, 3 to 2. This is an example where I've constructed only 3 flights, and I can go from 1 to 2 like so, 3 to 4 here, 1 to 3, 2 to 4, 3 to 4. So from any city I can get to any other city. Is it possible to schedule less than 3 flights but still have but still be able to travel from one city to another? Can anybody answer in the chat box? Okay. No takers. Okay. Right. Okay. So the minimum number of flights that you need for k cities is k minus 1, right? Because from a city there should be at least one flight, and you can prove this by induction. If I have k minus 1 cities already with k minus 2 flights that connect them together, and if I add one city, I only need one flight from that city to any of the k minus 1 cities, and they would be connected to each other because by induction. So you can say that's one way to look at it. So you would need to schedule k minus 1 flights so that you can get from one city to another city. Okay, any doubts in that? Okay, and okay, so you have two types of flights. You have transatlantic flights that fly over the Atlantic Ocean, and then you have trans-Pacific flights that fly over the Pacific. Okay, and so if you have let's say Africa, Europe, Asia, and let's say Australia here, and if you want to go to the Americas, either you go by the Pacific Atlantic, like so, or you go via the Pacific. Okay, so that's the only way you can get from either Europe or Asia to America. Okay, and traditionally what happens is these transatlantic and trans-Pacific flights, they are long flights. Okay, and yeah, so we want to schedule these flights to maximize profit. Okay, the only way you can get from Europe or Asia to America is by these transatlantic or trans-Pacific flights, which I'll together call long flights. So only by long flights you can go from Europe or Asia to America. So if every pair of cities is connected, there must be at least one long flight, right? Because if there are no long flights, then there would be no possibility to get to America from Asia. Okay, and that's one requirement. You need from any city, you need to go to any other city. So that basically says that you have to have at least one transatlantic flight, transatlantic or trans-Pacific flight. Okay, and your second goal is to maximize the profit. Okay, so how do I maximize the profit? So I have a number of flights to choose from, a number of transatlantic and trans-Pacific flights, and it's also given that you can reach from within Asia and from within Europe. You don't have to take transatlantic or trans-Pacific flights. That wouldn't make sense, right? If I wanted to go from Asia to Europe, or within Europe or within Asia, then I don't take transatlantic or trans-Pacific flights. There should be domestic flights that connect those two cities. So let's say Europe and Asia are interconnected, and you can they're all connected completely by flights. The only connect that you want to do is you want to connect America. So you can think of America as one big component, and the Americas, not South Americas, and then you can think of Asia and Europe, Africa and Australia as one component, and you can think of these transcontinental flights as being edges, or these transatlantic flights that go from one city here to one city here. Okay, and there are multiple flights here. Okay, and they have varying profits. Okay, let's say P1, P2, P3, P4. Since what you have to realize now is that it doesn't really matter which of these flights you choose. They are going to be connect. As long as you choose one flight, all the cities will become connected, because within Americas, you know that there exist flights to go anywhere from any city to any city here, and from within Asia and to Europe, you know that there will exist flights that go within there. So it's enough if you have one flight. Okay, it's enough to have one flight to connect these two and make them reachable from each other. Okay. The second thing is profit. Okay, so let's say you had you chose a flight P1 with a lower profit. Let's say a profit of 5, and let's say you had another flight P2 with profit 10. There is no reason why you should choose this flight over this flight. Okay, because if you remove the flight that costs 5 and add the flight that costs 10, you only increase your profit, right? So in all cases, it's optimal to choose the flight that has the highest profit. Okay, and that basically is the solution to this question. There must be at least one flight that is a long flight. Basically, it's a transatlantic or a trans-Pacific flight, and it has to be one among the flights that has the maximum profit. Okay, but you might have to schedule multiple flights because they may end up being some domestic flights that are not profitable at all. Okay, so you may end up having to choose more than one transcontinental flight, I mean trans Atlantic or trans-Pacific flight to maximize your profit, but there will be at least one, and that one will be the one with maximum profit. That will definitely exist. That's the only thing you can say about the graph, and so that's the answer for that question. Okay, going over to the next question. Right, Alice and Bob are playing a game, and there is a number x, let's say, and they take turns playing. So Alice plays first, then Bob plays, then Alice plays, then Bob plays, etc. And in each turn they are allowed to add any integer from 1 to y. Okay, so from x you can go to x plus 1, x plus 2, and so on. So let's say Alice plays first, and the goal is to get to 120. Okay, did everybody understand the question? Put a confused face if you didn't understand the question and you want explaining on the chat box. Okay, guys, can you give me some reaction in the chat box so that I have some feedback? Okay, cool. Right. So one example is, let's say you start with 119 and y is 1. Okay, so in one turn Alice can win the game by changing 119 to 120. Okay, so in this case, if x equal to 119 and y equal to 1, then Alice wins the game. Again, conversely, let's say x equal to 118 and y equal to 1, then Bob wins the game, because Alice will have to change 118 to 119, then Bob will change it to 120 and Bob wins the game. Okay, so this is simple pattern finding. So what you can do is, let's say f of x is 1 if Alice wins the game, and 0 if Bob wins the game. uh, it, so f of 119 is always 1 because Alice can add 1 to 119 and win the game. And to get f of x less than 118, look at f of x plus 1, f of x plus 2, and so on till f of x plus y. If any of these is 0, f of x plus 1 or f of x plus 2 or f of x plus 3 and so on till f of x plus y, if any of these y numbers are 0, then what Alice can do is, if Alex starts at x, then Alice will move to whichever number has the value 0. Let's say f of x plus 7 had the value 0. Alice will move to f of x plus 7, and then basically what that means is Bob is starting at x plus 7, and f of x plus 7 equal to 0 implies the person who's starting from x plus 7 will definitely lose the game. So Alice can win the game. Let's say a given state x is a winning state or a losing state. A winning state if Alice wins, and losing state if Alice loses. So just look at the next possible state, right? Next possible state can be x plus 1, x plus 2, and so on till x plus y. So amongst the possibilities that you have, if any of them is losing, then you move to that position, and from there on you know that the next player who's starting at that turn will lose the game and you will win the game. So f of x will be 1 only if one of these guys, x plus 1, x plus 2 to x plus y, is 0. Otherwise f of x is 0. So going by that, if y is 1 and f of 120 is 0, we'll initialize that, and so like that we can get f of x for all numbers x less than 120 by looking at these numbers. Okay, say f of anything greater than 120 also 0. And what you can do is, for different values of y, you can observe the pattern, and the pattern will look like so. 120 will be 0, 119 will be 1, 118 will be 1, and so on up to 120 minus y will be 1. Then you get a 0 from 120 minus y minus 1, because all these states are 1s, there is no 0 to go to. So 120 minus y minus 1 will be 0, and then 120 minus y minus 2 will also be 1, because you can go from this state to a state which is winning. Okay, so then 120 minus y minus 3 will also be 1, and so on. 120 minus 2y will be 1, and then 120 minus 2y minus 1 will be 0. So if you see the pattern, the numbers that are 0 follow like a nice pattern here, and by observing that pattern you can answer the question easily. Any questions? Cool, I'll get to the next question then. Okay, so the next question is, given the set 1, 2 through n, okay, choose how many ways are there to choose 3 different numbers. Let me highlight different. How many ways are there to choose 3 different numbers such that their sum is divisible by n? So one example would be, if you take n equals 3, there's only one way, which is 1 plus 2 plus 3, which is 6, is divisible by 3. Okay, and that, I mean, 1 comma 2 comma 3 is the only way to choose 3 different numbers here. But essentially given n, the question is how many ways are there to choose 3 different numbers such that their sum is divisible by n. Order doesn't matter, so 1 2 3 is same as 3 1 2 and so on. Okay, so can you guys give a thumbs up if you understood the question, or if there are any doubts in the question? Cool. Okay, so let's say you chose x, y and z. You want x plus y plus z to be divisible by n. Okay, and let's do overcounting. So one way to do this is count all triplets, assuming repetitions are allowed, and we will remove the repetitions later. Okay, let's say x can be any of n possibilities, 1 2 till n. Y can be any of the n possibilities, 1 through to n. My claim is that once you fix, if you fix x and y, there will always be a z such that x plus y plus z is divisible by n. Okay, why is that so? Very simple. If you take x plus y, let's say x plus y is anything, can be any number. The remainder when it's divisible, when it's divided by n, will be 0 1 2 or n minus 1, right? So whatever the remainder when x plus y is when divided by n, you can just choose n minus r. So if x plus y is divisible by n, then you can choose z equal to n. Okay, if x plus y is 1, then you can choose z equal to n minus 1, and so on. If it's n minus 1, then you can choose 1. So regardless of what you can, let's say you're free to choose the first two values. The third value, there will be exactly one value amongst 1 to n that makes x plus y plus z divisible by n. So did everyone understand that? Like, put a thumbs up if you understood that. Okay, let's consider n equal to 3, 1 comma 2 comma 3, and we have to choose 3 numbers, right? X plus y plus z. And let's not be worried about all the 3 numbers being different right now. Let's assume that they can be equal to each other. Let's say I chose x equal to 1 and y equal to 3. Okay, so x plus y is 4. Okay, and I want the sum to be divisible by 3. So I can add 2. So for the pair 1 plus 3, there is a number z 2 that makes the sum divisible by n. So if I chose x equal to 1 and y equal to 1, then I have z equal to 1 that satisfies the criteria that x plus y plus z is divisible by n. And only z equal to 1 satisfies this. So 2 plus 2 is not divisible by 3, 2 plus 3 is not divisible by 3, but 2 plus 1 is divisible by 3. So if I fix x and y, there will be exactly one value of z that will make x plus y plus z divisible by n. You can work around with examples. So let's say x is 2 and y is 2. Then I can choose z equal to 2 to make x plus y plus z divisible by n. The reason is that consider the remainder when you divide x plus y by n, right? It can be only n minus 1 values, right? Only of these n values, 0, 1, 2 or 2 through n minus 1. For each of these n values, there is a value, exactly one value here, which is n minus r, that makes x plus y plus z divisible by n. So the one person who couldn't understand, like, was it clear for you now? Put a thumbs up if you did, or another confused face, or type a comment if you didn't get it. Cool. Okay, so I am free to choose x and y, so there are n square possibilities. So there are n square possibilities to get, I have got n square triplets whose sum is divisible by 3, divisible by n, right? But the problem is some of them are repeating, and I have counted pairs like 1 2 3 and 2 1 3 twice, which I have to fix, but I'll get to fixing that a bit later. But I have n squared triplets at least whose sum is divisible by n. Okay, now let's say that exactly two of them are equal. If exactly two of them are equal, then it will be something like x x y. Okay, then that would mean 2x plus y is divisible by n. Okay, so these pairs x comma y, such that 2x plus y is divisible by n, will be counted in these n squared triplets, which I want to remove, which I'll subtract. Okay, so here what I can do, again, make x whatever you want. X can be 1 2 so on till n. For each value of x, you have 2x here. There will be exactly one value y amongst these 1 to n that makes 2x plus y divisible by n. So again, same argument that we had previously, right? So you can choose let's say 3 plus 3 or 2 plus 2 or 1 plus 1. For each of these three possibilities, there will be exactly one y, in this case 3, in this case 2, in this case 1, such that 2x plus y is divisible by n. So you have n triplets of the form x comma y, which are divisible by n. So freely choose x, and y will be fixed based on the remainder when 2x is divided by y. Similarly to how we found z in the previous example, we can get n triplets of the form x x y, and we will count this. We would have counted this triplet 3 times. One in the form of x x y, one in the form x y x, and one in the form y x x, when we counted these n squared triplets, right? So let me subtract all of them. Okay, and then finally, what about triplets such that all of them are equal, x x x? I would have counted them exactly once here, but I subtracted them 3 times here, because in this case, for some x equal to y is a possibility, and I subtracted those occurrences 3 times here, when in fact I should be subtracting only once. So I'll add 2 times number of triplets of the form x x x, which is divisible such that 3x is divisible by n. Okay, so the final answer is n squared minus 3n plus 2 times number of triplets of the form x x x. So if this triplet is divisible by n, that means 3x is divisible by n, and if 3x is divisible by n, then 3x can be n or 2n or 3n, because x is from 1 to n, so 3x cannot be greater than 3n, but it can be n or it can be 2n or it can be 3n. So 3x equal to 3n, you have one possibility. 3x equal to n and 2n, you will have will be possible only if n is divisible by 3. Okay, so then you have so if n is divisible by 3, you have x equal to n by 3 and x equal to 2n by 3, which is possible. So this will be 1 or 3, depending on if n is divisible by 3 or not. Three if n is divisible by 3 and 1 otherwise. Okay, and I have a confused face. Okay, I have one thumbs up. Cool. Let me the person who had confused face, if you can give a comment, then maybe I can address that, but I'll move on otherwise. Cool. Yeah, we have n squared minus 3n plus 2 or 6 by 6, and this is the answer. So this is equivalent to floor of n squared minus 3n by 6 plus 1. Okay, and there is also an OEIS for this, online encyclopedia of number sequences. I'll ask you to refer that as well if cool. And then finally, okay, we are only through 12 questions. Let me discuss let's say only the difficult questions from now on. Okay, let me discuss this one. Maybe this is new for you. How many ways are there to Abhishek? I mean, due to lack of time, I'll just skip for now. But you can try on your own, like trying to count the triplets without considering them as equal first, and then removing them by inclusion exclusion. Okay, let me quickly go through the questions again. You have, let's say, so let me just go over the interesting ones, because due to lack of time I'm taking too much time here. Right, so let S be the set 1 through n, and you have to divide it into two sets, A and B, such that the sum of A minus sum of B is minimized. Okay, and this is a constructive constructive problem. Like, you can construct a case where this is exactly 0 or 1, depending on whether the sum is even or odd, and you can't do better than this. So one example would be group every 4 numbers like this. Okay, put the first and the last in one set and put the middle two in the other set. Okay, put this in A, put this in B. So in each for each case, like what happens is 1 plus 5 equals 2 plus 3, 5 plus 8 equals 6 plus 7, and so on. So for yeah, like you can easily form pairs such that sum of A and the sum of B are exactly same, and if n mod 4 is 1, then just chuck out the first 1 and group the other 4. If n mod 4 is 2, then put 1 in A, 2 in B, and group the other 4, group every other 4 elements. And if n mod 4 is 3, then you can put 1 and 2 in A and 3 in B, and again proceed with grouping elements 4 by 4. So you can always get 0 or 1. So 0 if the sum of elements is even, and 1 if the sum of elements is odd. Hope that was clear. And then this is an interesting one. Let's say you start okay, so question is, you have a stick of length 10, and in each turn you are allowed to take a stick of length 10 and break it into two parts, A and B, and A and 10 minus A, and the cost for doing that is A into 10 minus A. Okay, and you have to keep doing operations so until you get 10 ones. So for example, in one turn you could break it into 3 and 7 for cost 21. Then you could break 3 down to 2 and 1 for cost 2, and then you can break 7 down to 3 and 4 for cost 12, and you can keep repeating this until you get, you should keep repeating this until you get 10 ones. And the question is, what's the total cost? Okay, and this is kind of a famous problem, and it turns out that if you try a few ways to do it, that it doesn't matter how you decide to split it from beginning to end, you always get the same cost, irrespective of whether you split it to 3 7, split it to 5 5, etc. So one way to split would be 1 comma 9, then 1 1 8, and so on. This will have cost 9 plus 8 plus 7 plus so on till 1, which is 9 into 10 by 2, which is 45, and every other way will also give you 45. So the minimum is also 45. Cool. That was an interesting problem. The rest I'll just leave it. Okay, I found another interesting one, and I'll wind up with that. So suppose you have I'm assuming you're all familiar with the divisibility test for 3. So what you can do, for example 2021, you can replace 2021 by the sum of the digits. 2 plus 2 plus 1 is 5, and you can keep doing this until the remaining number is less than 10, and if the remaining number is divisible by 3, then your original number was divisible by 3. And more specifically, the remainder when it's divided by 3 is the same. So the remainder when 2021 is divided by 3, when divided by 3 is 2, and the remainder when 5 is divided by 3 is also 2. Okay, and the reason is, like, you can write 2021 as 2 into 1000 plus 2 into 10 plus 1, right? and the remainder when 10 is divided by 3 is 1, because 10 is 3 into 3 plus 1. So you can replace all 10s with 1s, and in the eyes of remainder when divided by 3 they are the same. Okay, and yeah, this is because 10 modulo 3 is 1. So you can extend this for other bases as well. So instead of base 10, like the question asks for base 16, what would be what numbers could you test for divisibility using similar procedures? So if 16 modulo y is 1, then you can do the same procedure. Consider the number base 16, add the just blindly add the digits, and keep doing it until the number is small, and then find the remainder at the end. Okay, and so you can do it only if 16 modulo y is 1, and that is true only for among the options. It was 15, 3 and 5. Okay, so yeah, there was a mistake. It 6 was also an answer, but 6 is not correct, because 16 modulo 6 is not 1. So that was a mistake, and sorry for that. Yeah, so with that I'll maybe conclude the session. If you guys had any question that you want to discuss, okay, you can put it in the chat box amongst the question that I didn't or skipped. Hello, I'm a newbie in programming and I have to learn from it. Yes. Yeah, coming to the presentations. Yeah, so CodeChef has partnered with an academy to give you some curated classes. To give you some live classes that are hosted on an academy. So they are taken by world-class faculty, like people who have been ICPC World Finalists, IY Bronze Medalists, etc., and software engineers at Google, LinkedIn, etc. So there are some special classes as well tomorrow, which are free for everyone. Let me just put the link on the description box below. Okay, so tomorrow there will be a set of beginner classes for that basically show you how the plus classes would be. That is tomorrow we have the links aren't clickable. Well, it works for me. Maybe try copy pasting it. Well, for me it works. Okay, yeah, so tomorrow there are a bunch of special classes that you can attend for free to get an idea of what the plus classes would be. And what you get is you get to interact like how you did today on the chat box with educators, with these educators, and after that you get a specific practice problem session based on the classes that are conducted, and then you can ask your doubts. There are Discord forums and discussion forums where you can ask your doubts, and I believe you can go to IARCS website to register for IOI. Please, I guess it should be there in the just Google IARCS and you'll get the link. And I'm not sure when it's happening this year, but the link should be available there. Right, so coming to the courses, so there are a number of courses, beginner, intermediate, and advanced, that are discussed. And tomorrow there's an introduction session by Ria for Java, and then she'll be taking course later. So if you're a beginner, then you can consider joining in that session tomorrow to see how the class is. And so there's a specific discussion forum and a Discord server also, where you can ask your questions and the TAs will answer your doubts there. Right, and then it leads to the free classes lead to plus classes, which you have to pay to get. And there are these subscription plans which you can check out, and you can put this coupon CodeChef to get some discounts. And that's it regarding the subscription. So feel free to check it out if it's right for you. So that's it, and I'll end my session there if there aren't any doubts.